Hello, welcome. I'm Rob Honey, the current president of EPS, and one of the great joys is to introduce the prize winners each year. As many of you will know, the EPS gives out 4 prizes to individuals at different stages in their careers. The first of 2 prize talks this afternoon is the EPS Undergraduate Project Prize, which is collaboratively sponsored by the British Science Association. And this prize recognises someone at an undergraduate level who's done some excellent research. I've read the project, it's absolutely fantastic, and intends to go on to do postgraduate research or training in psychology. You're already doing that, that's fantastic, so it's true, it's great. So this year's winner is Didem Yurdakul. Is that about right? Sorry. And she studied for her honours degree at the School of Psychology in the University of Aberdeen. And what she's going to do is tell us about her project, which is written up there, the effects of repeated lineups on accuracy and choosing. So if you'd like to join me in welcoming Didem to the stage, that'd be brilliant.
Hi everyone. My name is Didem, and I'm excited to be presenting the effects of repeated lineups on accuracy and choosing today. If someone became witness to a crime, they would likely be asked to first describe what they saw, and at some point during the investigation, they might be asked to try and identify the perpetrator or the person that committed the crime from a suspect lineup. We've probably all seen lineups like this one in movies or TV shows where several people will be lined up holding out a number in front of them. A police officer would ask the eyewitness to point out if anyone in the lineup looks like the perpetrator. Eyewitness ID procedures are not only commonly portrayed in media, but they can act as highly useful tools in real investigations in helping to identify and convict criminals as long as they're administered appropriately and without bias. The issue that comes with procedures here is that suspects placed in lineups aren't always guilty, and eyewitnesses have been known to make mistakes. Research in this field has been committed to creating guidelines with the aim of minimizing the number of mistakes eyewitnesses make, while also maximizing the number of correct identifications of perpetrators. Some examples of pristine conditions include the use of double-blind procedures, meaning both the administrator and the eyewitness don't know who the suspect is. And another one would be only presenting one suspect alongside good fillers. Fillers are typically known to be innocent individuals that match the description of the perpetrator placed next to the suspect so they don't stand out. One policy recommendation especially of interest to this study is the avoiding of repeated ID procedures using the same suspect and same witness. The reason so much importance is placed on creating these policies is because we've seen what happens when these guidelines aren't followed. Often what can happen is that eyewitnesses' mistakes are overlooked. The DNA exoneration cases carried out by the Innocence Project made evident just how disastrous the consequences of such mistakes can be. They reported that 69% of 375 DNA exonerations involved eyewitness misidentification, which made it the leading contributing cause of wrongful convictions in the US legal system. To illustrate, decision-making and memory errors were likely the reasons behind the wrongful conviction of John Jerome White, who's pictured here with his mother right after being freed. White was falsely convicted for several crimes in 1979 and was only exonerated using DNA evidence after spending 22 years in prison. He was identified as the perpetrator from a photo lineup by the victim of this case 6 weeks after the crime took place. Following this, she picked him out again from a live lineup in which White was the only repeated suspect. Pictured here, we have the second lineup, which White wasn't picked out from. What makes this case specifically so unique is that in the second lineup, the actual perpetrator, James Parham, who's on the far right, was coincidentally used as a filler alongside White. So even though the perpetrator was present in this lineup, the victim still picked out White as guilty, not recognizing her attacker Parham. While White's name has since, undoubtedly much too late, been cleared, the question as to why she falsely identified White as guilty with the actual perpetrator present still stands. One crucial policy recommendation that aims to avoid mistakes like this one was added in a recent review paper by experts in the field, and it was stressed here that repeated attempts of identification with the same witness and suspect should be avoided, and only the first attempt should be focused on. The reason for this is that once an eyewitness ID has been collected, any subsequent tests will be contaminated by the first, as was likely the case with White. Even though this has become generally accepted, some jurisdictions, to some extent, do make use of repeated eyewitness IDs. For example, one case of repeated ID would be when sometimes witnesses are asked to look through a mugshot book and point out any individuals that resemble the perpetrator. After doing this, they might still be called back to attempt to make an ID from a lineup, which again may contaminate witnesses' memory and lead to misidentifications. Similarly, sometimes in the Czech Republic, eyewitnesses who make an ID from a lineup are presented with a second lineup in which the positions of the same lineup members are shuffled. The reason they give for doing this is that the second lineup serves as a way of testing eyewitnesses' credibility. They say it's to identify individuals that might have guessed on the first lineup, since they wouldn't be able to necessarily repeat this ID on the second lineup. The issue with doing this is likely, rather than aiming to identify the perpetrator, eyewitnesses may instead recognize who they selected from the first lineup and commit to picking out this occasionally innocent individual again. One problem that's been noted with other forms of repeated lineups is that eyewitnesses who misidentified an innocent suspect at the first trial are very unlikely to make this mistake in the second. They're unlikely to correct this mistake in the second trial. This procedure of repeated lineups I just described and its possible effects on accuracy and choosing were investigated in the present study. Essentially, what we were interested in here is to uncover whether the use of such repeated lineups comes at a similar cost to what's frequently been found with other forms of repeated lineups. And it has once even been observed with a procedure very similar to the one of interest here. Some theoretical frameworks that we consider to help inform our predictions are those of source monitoring and familiarity misattribution, commitment, and misinterpretation. This source monitoring framework describes ideas regarding cognitive functions with which humans attribute thoughts, feelings, and information to specific contexts under which these experiences were generated. The thought here is that when eyewitnesses see a second lineup, they might make a source monitoring error by misattributing their memory of the face or of the faces from the first lineup to the memory of the original event. Familiarity misattribution similarly states that if eyewitnesses are exposed to guilty or innocent suspects in any form, this increases the chances of them identifying this person as the perpetrator in a subsequent lineup. Essentially, commitment effects describe that regardless of what ID eyewitnesses made initially, it's likely they'll stick to this decision and make the same ID should the opportunity arise. So even if the suspect identified in the first instance was innocent, they might pick the suspect again if they are presented with this opportunity. Eyewitness testimony procedures tend to have delays in between identifications that can range from minutes to days or even months. Studies that only employed short delays, similarly to our study, also note the presence of such commitment effects. Common consequences noted in previous studies that report commitment effects are: 1, the decreased accuracy of eyewitness IDs from subsequent lineups, as well as the general increase in choosing for subsequent lineups. In cases where the suspect is the only repeated person across lineups, it's thought that eyewitnesses who initially didn't identify anyone and rejected the lineup later on might recognize the only common individual and consciously decide to identify this person because they realize that this must be the person that the police are investigating. The investigation of other social influences like post-identification feedback or being asked to re-examine can cause eyewitnesses to change or make an identification subsequently, which often results in impaired performance. While these exact concepts may not be possible when all lineup members are repeated, it's plausible to assume that the idea of misinterpretation may be transferable to the present study. Perhaps being offered the same lineup again acts similarly to being asked to re-examine. If this was the case and the second lineup was considered as an opportunity to correct a previous mistake, then this might be reflected in an increase of choosing for the second lineup. And by choosing, we mean selecting someone from the lineup as the perpetrator. For confidence, which confidence here refers to how certain a witness is that the statement they've given is correct. In recent developments in eyewitness testimony, it's been concluded that generally if a strong CA relationship is established, then high confidence reported by eyewitnesses will typically be informative of accuracy. The question that arises on whether repeated lineups will show a weaker or possibly even stronger confidence accuracy relationship was also investigated here. For this relationship to become weaker, confidence and accuracy would have to drift further apart. Such a shift could be brought about if confidence somehow decreased for subsequent identifications while accuracy did the opposite. What you see up here is one way to gauge this relationship by using confidence accuracy characteristics curves, or CAC curves. And the main takeaway from these are that as confidence increases, so does accuracy. This is what the design of the experiment looked like overall. There were many combinations of videos and different lineups that participants might have seen, but this is one of the possible flows that could have occurred. To test whether immediate repeated lineups would affect choosing and accuracy, participants viewed a two-target mock crime video displaying a theft, like this one, and following this, they completed 5 minutes of filler tasks playing the game Snake and Sudoku. This filler task delay is what we call an initial delay, and the purpose is to prevent the rehearsing of information. After this, they viewed one set of repeated lineups for one target, which would be male or female, in this case female, from which they either identified one individual as the perpetrator or they rejected the lineup. After making a decision for the first lineup, the position of lineup members was shuffled, and participants would make another identification from the second lineup. Following this first set of lineups, the remaining target lineups would be presented following the same structure. This time, the other target would be under investigation, and in this case, participants saw a target absent female lineup first and saw a target present lineup second. For this lineup specifically, the correct decision would be to identify the person highlighted in red from both lineups, as this person was present in the mock crime video. For the lineups, one target was always present, meaning the perpetrator was included as one of the lineup members, while the other set of lineups was target absent, which essentially mimics a real lineup where the suspect is innocent. Participants were asked to indicate their confidence after each decision, and importantly, they were also told that the perpetrator may or may not be present in the set of photos to ensure they knew rejecting the lineup was a viable option. Now, for our predictions, we considered evidence from previous research and made predictions for changes in choosing, accuracy, and confidence for subsequent lineups. First, an increase in choosing for the second lineups was predicted. Increased choosing only becomes an issue if it doesn't also come with an increase in accuracy. So for our second hypothesis, alongside an increase of choosing, we expected to find a decrease in accuracy for target absent lineups. And finally, based on theories around confidence inflation, which means confidence will increase for the subsequent lineup, from first to second lineup, it was predicted that the confidence-accuracy relationship would be weaker for the second choice than for the first choice, as a result of conflated confidence combined with the expected decrease of accuracy for the second lineup. We expected this relationship to be weaker. To conduct the power analysis, the discordant pairs, meaning participants who identified from the first lineup and rejected the second lineup, and vice versa, were taken from a previous unpublished study that conducted this experiment online. We landed on a target sample size of 100 after conducting a power analysis using a two-sample dependent proportions test power calculator. Quite a mouthful. Since each participant provided decisions for two lineups, first and second, this would provide 200 repeated decisions for 100 participants. Using these numbers, we expected a power of around 84%. The target sample size that was set for the study was reached with a total of 106 participants. taking part in the study, with a mean age of around 24 years. The measured variables included lineup decisions and confidence. From participants' lineup decisions, accuracy rates, choosing rates, and identification decisions were calculated for data analyses. An accurate response for target present lineups meant participants correctly identified the perpetrator from the lineup, which would be a hit. In target absent lineups, an accurate response would be to reject the lineup and say the target wasn't present. And inaccurate decisions included participants rejecting a target present lineup instead of identifying the guilty suspect, or identifying any lineup member that wasn't the perpetrator. This table shows the proportions of all identification decisions participants made in both lineups, target present and absent, for the first and second lineup. Generally, participants that had a hit in the first lineup also did so in the second lineup, as seen in the 42 versus 43% respectively. The slight increase of filler ID in the second lineup compared to the first lineup, as well as the decrease of incorrect rejections from the first lineup to the second lineup, reflect a slight trend in the predicted directions that accuracy would decrease and choosing would increase. In a similar manner, the target absent condition shows that some participants that correctly rejected the first lineup did not do the same in the second lineup, but made a filler ID instead. What I can already tell you is that none of these differences were significant in our data analyses. And to test the first hypothesis, which stated that choosing would be higher for the second choice, it was noted in the pre-registration that a McNemar's test would be run to compare the proportions of choosers between first and second lineups. But since responses of participants tend to be more correlated within subjects than between subjects, the choosing variable, which had 4 instead of just 2 data points per participant, would have had more correlated responses, which a McNemar's test can't account for. So we opted to additionally analyze the data by using a generalized linear mixed model. And not in line with the predictions, both analyses suggest that repeated lineups don't seem to cause an increase for choosers for the second lineup. Considering the small effect size, the true effect seems to be much smaller than we originally expected, and the power was likely way too low to detect it. But while it isn't significant, it's noteworthy that there does seem to be a slight trend going into the predicted direction. And to test the second hypothesis, here again, the findings were not in line with the hypothesis, but we decided to run a McNemar's test, and since we only used a subset of data for the target absent lineups, it was enough to just run the McNemar's test. And similarly to the choosing variable, that does again seem to be a very slight trend in the predicted direction, but this is very likely just by chance. And more importantly, it should be highlighted here that there doesn't seem to be an increase of accuracy either. For both the choosing and accuracy variables, sufficient power couldn't be ensured, meaning the possibility of a type 2 error shouldn't be ruled out either. To evaluate the third hypothesis, that confidence-accuracy relationship would be weaker for the second choice than for the first choice, CEC curves were conducted. These plots help to determine the trustworthiness of eyewitness identifications by showing whether self-reported confidence statements are closely related to accuracy of their decisions. It seems to be clear that the relationships in the first and second choice are nearly identical. Especially high confidence statements seem to indicate a highly accurate identification, meaning these findings again don't support the hypothesis. Finally, a linear mixed model was conducted to test the difference between confidence statements in the first and second lineups, and again, confidence didn't differ significantly between the first and second lineups. While we didn't make any predictions for the consistency of IDs, exploratory analysis showed that overall, regardless of choosing an accuracy, 78% of participants were consistent or committed to their decision. But consistency didn't necessarily indicate a correct choice. For instance, 45% of participants decided to identify someone from the first lineup that wasn't the perpetrator. In 73% of these cases, participants committed to this, even if the actual perpetrator was present sometimes. Only 9% that made a filler ID for the first lineup corrected their mistake. And in 14% of cases, participants rejected the first lineup, but then chose a filler from the second lineup. So we failed to find support for any of our hypotheses. This should be a good thing, right? If there doesn't seem to be any cost to using repeated lineups, then surely you'd be fine to continue using them. Well, what we found seems to be inconsistent with the findings of other repeated lineup experiments. For instance, Lin et al., who investigated a very similar procedure, found that choosing increased for the second lineup, which they attributed to misplaced familiarity. While we didn't find the same increase, we did find similar familiarity misattribution that might be taking place. It could explain cases where participants chose from both lineups but decided to identify a different person in the second lineup. And it could also explain cases where the first lineup was rejected, but someone was, regardless of target presence, selected from the second lineup. Earlier, I also described that participants may regard being presented with a second lineup as a chance to correct their previous mistake, as if they were being asked to re-examine. And in between the first and second lineups, we provided a set of instructions with the aim to minimize such effects. The instructions prior to seeing the second lineup stated that this presentation is unrelated to the accuracy of your previous decisions, it's just another way of presenting the photos. Perhaps this can explain why no increase in choosing was observed. The fact that no changes were observed from first to second lineup in accuracy or the CA relationship does seem to align with previous research. Then it all showed no significant increase or decrease as a result of repeated lineups, as was the case here. Importantly, there wasn't an increase of accuracy associated with repeated lineups for either study. The fact that confidence didn't differ between the first and second lineup indicates a possible confidence carryover instead of the expected confidence inflation effect. Considering that accuracy and confidence both stayed constant across lineups, it makes sense why no change in the CA relationship could be observed, which again aligns with Lin et al. Multiple factors, including limitations of the study, were considered as possible alternative explanations for failing to find the predicted effects. We'll look at delay, the possibility of a type 2 error, a younger sample, online versus in-lab testing, as well as overly stressful filler tasks as possible explanations. For one, the only substantial procedural difference between the present study and that of Lin et al. Was the missing delay between the first and second lineups of our study. While they do state that regardless of delay, the tendency to choose from the second lineup was greater than for the second than for the first lineup, their subsequent delay was always at least 1 day, whereas the present study had at most a delay of a few minutes that it took to read the instructions. So perhaps longer delays serve as the crucial aspect that leads to participants developing an increased sense of familiarity or misinterpretation that may cause an increase of choosing. They also found that participants were more likely to choose after a short initial delay, meaning 10 minutes between seeing the video and the first lineup, compared to a 5-day-long delay. They explained that participants likely felt less confident in making a positive ID after a long delay. The initial delay of the present study was only 5 minutes long, so it makes sense to assume that because the initial delay was so short, participants likely feel confident in their ability to correctly identify the perpetrator, which could explain the high proportion of choosers for the first lineup, and therefore also the missing increase of choosers. Alternatively, a type 2 error shouldn't be disregarded as a possible explanation, because Lin et al. Recruited several hundreds of participants, and considering that in eyewitness ID research, typically participants don't provide more than one data point each, thousands of participants may be required to receive an accurate idea. And as outlined earlier, this present study was unsurprisingly underpowered, even though higher power was predicted for the same sample size. Perhaps this can partly explain why no increase in choosing could be detected. Additionally, while it's unlikely to have contributed much to the results, the generally young sample of the present study shouldn't be disregarded entirely. The sample in Lin et al. Study was varied highly in age, whereas the mean age of the present study was only approximately 24 years. And according to past research, aging has been associated with a decline in discriminability, which is the ability to differentiate guilty suspects from innocent suspects, which could have caused the change in the findings. And finally, Lin et al. Conducted their study online, which, as they state themselves, may lead to higher distraction of participants, which in turn may cause participants to feel less inclined to choose initially, but might then lead to an increase of choosing from any subsequent lineups. In contrast, the present study was conducted in a lab under less distracting conditions, which might have made participants feel as though the second chance wasn't required to make an identification. This could explain why, in contrast to Lin et al., a commitment effect, but no increase of choosers could be detected for the second lineup. The first filler task, which was the game Snake, was surprisingly deemed extremely difficult and very stressful by many participants. I think the snake was just moving too fast, but in the early stages of the data collection process, we aimed to correct for this by telling participants to just not worry and have fun with the game. But regardless, most participants expressed high concerns about their performance after taking part. So it's worth considering that such stress may have had unintended effects on their eyewitness decisions, which might have differed had less stressful filler tasks been used. The literature provides mixed findings on the effects of stress in eyewitness ID, with some finding support for this notion and more recent ones finding the opposite. Right, so what can be gathered from these findings as they stand seems to be that even if eyewitnesses were presented with a second lineup, including the same members in shuffled positions, their identification should likely be just as accurate for the second lineups as for the first, provided they indicate high confidence in their decision. The primary goal of eyewitness ID research is to develop procedures with which correct IDs can be maximized while false IDs are minimized. On the other hand, if repeated lineups were found to increase likelihood of choosing without also increasing accuracy, then this practice shouldn't be recommended. But if the findings had shown that choosing as well as accuracy increased, then this would have shown this practice to be favorable in the interest of increasing correct IDs. The present results showed that neither was the case. So ultimately, choosing didn't increase in a meaningful way, accuracy didn't decrease as predicted, and the confidence-accuracy relationship appears unchanged for the first and second lineups. Importantly, though, there doesn't seem to be any benefits to presenting eyewitnesses with the second lineup either. Consistent with the present literature, explorative findings of the present study showed that only very rarely did participants choose to correct their mistakes from the first lineup. This means that even if immediate repeated lineups don't seem to weaken eyewitnesses' performance, the fact alone they don't at all seem to improve performance means their use is discouraged and shouldn't be recommended, even if only not to waste any time or precious resources. That is everything from me today. Thank you so much for your attention.
Brilliant, thank you. Question?
Am I right in thinking that the eyewitness performance is just terrible overall? That you're only about 35? Sorry. The actual ability of people to remember the correct person was only about 40%, is that right?
That is right, but what's also important is, I'll go back to this slide.
I guess I'm just interested, how does that relate to the findings in the literature? Is that the norm? Is that how? That's
usually the norm. Eyewitness ID used to be regarded as unreliable entirely until confidence started to be taken more into account. So here we wouldn't really, or the police wouldn't really go forward with any investigations if participants or eyewitnesses didn't indicate high confidence. So here we're really only interested in the 90 to 100% confidence decisions, which do show high accuracy. So that's generally what it's like in eyewitness ID research.
And that's only a small amount of people you actually tested, I guess, that are both highly confident and highly accurate.
Yeah.
Fantastic, thank you.
Thank you for your question.
Very nice talk, very, very interesting. I just wanted to ask a similar kind of question about the kind of field and the sorts of things that people do in this sort of process. And that is, that as far as I understand it, in your instance, with each of the lineups, someone had to select a particular person. There wasn't I'm not going to pick anyone option, or was there? I couldn't remember if that was the case.
Oh, sorry, I couldn't quite hear
so
that. So,
in the process of me seeing 6 people, or whatever it was,
yes.
Was the question you're being asked as participants is pick one of these people if you think they were the case, or do you also have the option of picking no one?
No, they had the option of picking someone or rejecting the lineup, so not choosing anyone from the lineup. And that was true for all the pictures they were presented with.
So when you were talking about the representation of someone biasing me and thinking me that very plausible hypothesis of me saying, well, I'm seeing that guy again, and the police must be, doing something here. It seems intuitively that you'll be more likely to do that if you had actually said no to all of the people in the first instance. In other words, I've looked at 6 people, I don't think it's any of those people, and then I'm asked to come back again. I'd see 6 people and I see that bloke again. Now, I'd be more likely to say, oh, actually, it must be him, rather than any other situation where I may have picked somebody else or otherwise. Is that largely true? In other words, is it really only the instances when people have picked no one in the first instance that you're more likely to have this repeat presentation effect?
Yeah, I mean, it's been found in many studies. So specifically using the same suspect and the same witness and not using other fillers, like the first example with John Jerome White. Sorry. Here. So if a person selected someone from a lineup like this and then was asked to come back and the only person that was there still was the suspect, we would expect they would be more likely to pick this person again. So yeah, I hope that answers the question.
Any other questions before we think? No? Well, thanks again for speaking to us.
Thank you
That's a
so
great
much.
talk.